In this lesson, we're still working with our special quadrilaterals, but now focusing on the diagonals. So what we've talked about in the past is how in all the parallelograms here, so the parallelogram, the rectangle, rhombus, and square, diagonals bisect each other. So no matter what, the diagonals will always cut each other into two congruent pieces. However, now we are going to be discussing, and you can use this chart. We're focusing on the diagonals that are congruent to each other and are perpendicular, creating that 90 degree. So using this chart so you guys can understand, so like for the parallelogram. In the parallelogram, the diagonals, of course, still bisect each other. However, they are not congruent to each other and are not perpendicular. So they only truly bisect each other and cut each other into two congruent pieces. So like here, for example, if this section is 4, then this section is 4. If this section is 8, then this section is 8. So they cut each other into two congruent pieces. Now the rectangle, the diagonals are congruent to each other. So they are equal to each other, but they're still not perpendicular. There's no 90 degree. So like, for example, with our rectangle here, if this diagonal overall, let's say is 20, then the other diagonal is also 20. That means too, because they bisect each other, each section is 10 because they bisect each other into the congruent pieces as well. Now the rhombus, here the diagonals are not perpendicular, but they are now, or they're not congruent, they are perpendicular to each other. So they're creating that 90 degree. So they are not congruent to each other, but they now do create that 90 degree angle. And of course, remember, they still bisect each other. And then the square, the diagonals are congruent to each other and create that 90 degree angle. So these are the attributes that we're going to be focusing on and using here today. And if we need to, go back to this chart. So like, for example, in our parallelogram, we're just going to solve for W and Z. Remember, the parallelogram is the basic. It doesn't have truly any of those special characteristics except for how they bisect each other. So like, for example, if I want to solve for W and this piece here, EJ is 3W, and this section here of that same diagonal, JG, is W plus 8. That means if it's bisected, they are congruent or equal to each other. So to solve for W, we just set them equal to each other. 3W is equal to W plus 8. And then just go through and solve for W. So gathering my variable, and 2W is equal to 8, divide by 2, and W is equal to 4. So go ahead and pause the video and solve for Z on your own. And here we go. So again, you should have seen that here are two values, our two terms, with Z are on that same diagonal that are being bisected. So they are equal to each other. So 4Z minus 9 is equal to 2Z. Then go ahead and solve. Now, this is a key when solving. If I see a variable by itself, if it's alone, leave it alone. I'm going to gather the 4Z and subtract 4Z now from both sides, bringing down -9, which is equal to -2Z. So now dividing both sides by -2, you end up with Z is equal to 9 over 2. So now the rectangle. Remember now, and if you need to, go back to the chart. Well, what do you remember about the rectangle? Well, not only do the diagonals bisect each other, but now they're also equal to each other. So BD is here. BD is this diagonal, which is 41. AC is this diagonal here, which is 12x minus 19. So now remember the rectangle, the diagonals are congruent. They are equal to each other. And I just realized we're missing the question here. Let's just go ahead and just solve for x. So if I want to solve for x, how do we set this up? Set them equal to each other. So 12x minus 19 is equal to 41, and then solving for x. Adding the 19 and then divide by 12, and x is equal to 5. So take a look here and pause the video and label, where is EC? Where is AE? And keep in mind what we're solving for in this problem. And here we go. So EC, so I'm going to go ahead and erase from the previous problem. So EC is here, this section, 2x plus 13. And AE is the other section of that same diagonal, 5x plus 1. So again, remember, right? Not only are the diagonals congruent to each other, they bisect each other, just like in the parallelogram. This is a type of parallelogram. So how do you set this up to solve for x? You should have set them equal to each other. So 2x plus 13 is equal to 5x plus 1. Then gathering our variable to solve for x, subtracting 2x. So now I have 3x plus 1, and now we're just solving our two-step here, subtracting that 1, and divide by 3, and x is equal to 4. So is this our final answer? Well, no, because look back at the question. We're finding the length of BE. So now we got to think about, okay, how do I find the length of BE? Well, let's go ahead and plug in x to where we know, right? So I can plug in x into, let's say, 5x plus 1 or 2x plus 13, right? Because no matter what, they are the same. They're equal to each other. So like if you were to plug in for AE, which is the 5x plus 1, or 5 times x, which is 4 plus 1, AE is equal to 21. And then same thing, if you plugged into EC, you also get 21. So now we have to remember, okay, well, this piece is 21. This section is 21. And then remember the rectangle, the diagonals are congruent to each other as well, which means what does BE then have to be? 21. So now the rhombus, let's go ahead and label BD. So here's BD, this whole section here, right, is 24. And AC, this whole diagonal here, is 10. So now remember, we have to remember about the rhombus. They are not congruent to each other, clearly, right? Because one is 24 and one is 10, but they do bisect each other. And let's add this in. What is the other attribute now for the rhombus? They're perpendicular. So let's add, we've got that 90 degree. So we have that 90-degree angle. They are perpendicular to each other. So here we go. What is the length of BP? Well, here is BP. Well, if the whole diagonal is 24 and it's being bisected, that means BP then has to be 12, because 12 and 12 make your 24. So then here, like for example, if we wanted to know AC, right? If this is 10, then those two pieces are 5 and 5. So now let's go to the next. What is the length of AD? Well, where is AD? AD is here. So how are we going to find AD when it's actually one of the sides of the rhombus? Well, let's use the attributes from the diagonals. Here, I notice that this section is 12. We also know that this section here is not 10, right? Because it's half of that because it was bisected. So this section is 5. Now notice here are 5 and 12, and we're looking for this side here. What shape did we just create by focusing on those pieces of our diagonal? A right triangle, because they're also perpendicular. So how do we find the third length of a right triangle when we're given the two sides? Pythagorean theorem. 5 squared plus 12 squared is equal to c squared. Go ahead and pause the video and continuing solving for AD on your own. And here we go. Now, I did notice I just put C here, but again, that's the same as just our X, right? Because we're looking for the hypotenuse. So I've got 20, oops, sorry about that. So I've got 25 plus 144 is equal to, I'll go ahead and switch out that X squared for those who did X here, which is 169. But then always remember, right? What is always that last step to finding distance? Taking the square root. So the length of AD is 13. So AD is 13. Then what is the perimeter of the rhombus? Well, how do we find? Well, here, perimeter is adding up all the sides, right? Well, what do we know about the sides of the rhombus? They're all equal. They're all the same. So if AD is 13 and AB is 13, BC is 13, CD is 13. So the perimeter is adding up those 13s, or just 13 times 4, which gives you a perimeter of 52. That is the perimeter of the rhombus. And so now our last figure is the square. So let's go ahead and label. Our square BD is 10x minus 7. So BD is our entire diagonal here, 10x minus 7. And then AC, which is also the other diagonal, which here is 12x minus 9. So here are full diagonal. Then again, now we need to remember, what do we know about the diagonals in the square? We'll look back and you'll see that the diagonals are again congruent to each other and perpendicular, so creating that 90-degree angle. So notice how if the diagonals is what's given to us and we're looking for the length of AC, then how do we first need to solve for X? If the diagonals are congruent to each other, set them equal to each other. So 10x minus 7 is equal to 12x minus 9. And going through and solving for x. So gathering our variables, negative 7 is equal to 2x minus 9. And now we're back to solving our two-step, adding 9. And 2 is equal to 2x, which means x is equal to 1. But again, is this our answer? No, because we're looking for the length of AC. So AC was 12x minus 9, or 12 times 1 minus 9, which means AC is equal to 3. So here, if we want to continue on, or before we continue on, I'll go ahead and erase, so now we can start our labeling. Because we're going to use all of this for this problem, just like before. So if AC here is 3, the full length is 3, then that means BD is also what? 3. So here, remember, right, we have that perpendicular, that 90-degree, the diagonals are congruent and bisected. So we have 3 and 3. What is the length of DO? Well, here is DO, which is only half of the diagonal. So then what is the length of DO? Well, if the diagonal is 3, then what is half? 1.5. Which means if they're congruent, then all of those little pieces, right, are 1.5. So now the next question is asking, what is the length of BC, which is here? Now we're focusing on the side length of our square. Well, again, if you recall, we have what's connected. Well, we have this section here, which do we know what BO is? Yes, because if DO was 1.5, then what is BO? 1.5. We also technically know what CO is, right? Because the diagonals are congruent to each other. So everything is equal. So CO is also 1.5. We also know that they're perpendicular to each other, creating that 90 degrees. So again, what do you notice? What did we just create? A right triangle. And again, what do we use to find the length of a right triangle? Pythagorean theorem. So go ahead and pause the video Set this up and let's see what you get. And here we go. So I've got 1.5 squared plus 1.5 squared is equal to x squared. So now I've got 2.25 plus 2.25, which is equal to, whoops, my fault, that's x squared, not x to the fourth, which is equal to 4.5 after adding them together. And of course, what is always that last step? Take the square root. So x, or that side length of BC, is approximately, let's round to the nearest tenths, 2.1. So BC here is approximately 2.1. So then the last question, what is the perimeter of the square? Again, adding up all the sides of our square here. Well, what do we know about the side lengths of a square? They are also all congruent. So if BC is 2.1, AB is 2.1, AD is 2.1, CD is 2.1. So we add them all up or just multiply by 4. And the perimeter is approximately, right, because we rounded, 8.4 units.